Hello and welcome for this last talk of the 7th edition of the Legacy of SoCraTes. I am with Jim Humelsine, who also you may know under the name of Design Pattern Evangelist. I think you may know him because he's really active in some communities I belong to. So, for example, the coding blocks community, but is also present in the Legacy Cut Rocks community, and I know some of you are present in this community. So, Jim is here. And he's going to talk about hexagonal architecture. So if you know hexagonal architecture already, and we mentioned that before with Cyril and Living Documentation, you know that it's good. And actually, it's one of the patterns I guide people towards when refactoring legacy architecture. The thing is, in my experience, and we were talking with Jim and in his experience too, many developers out there don't know about this. So you may find some resources online to explain what is this architecture, but I found that we don't have yet one exhaustive talk that will present everything that is to know about this architecture. So this is also why we're doing this. It's really valuable, and very soon you'll be able to share that video with your colleagues so they can discover the benefits of this architecture. Without further ado, Jim, the stage is yours.
Thanks, Nicholas. I'm going to talk about hexagonal architecture. I think it's really neither hexagonal or architecture, but it's really much more. And as Nicholas stated, here's some of my contact information where you can reach out to me afterwards if you have any follow-up questions. So let's talk about, I want to talk about the inspiration for this talk. In the previous Legacy of SoCraTes, Matthias Novak gave a presentation on design patterns, and as you can tell by my handle, design patterns are a real passion of mine. And he had two diagrams, and I said, hey, wait a second, I think these are hexagonal. This is a hexagonal architecture he's talking about. And I reached out to Nicholas through the Coding Blocks Slack group, and we started chatting, and so that's how this talk came about, to go into more details about what Matthias introduced about 3 months ago. So hexagonal architecture originated in 2005 by Alistair Coburn, who's one of the Agile Manifesto's authors as well. And here's a picture of him presenting it from a YouTube series. And he draws hexagons to represent it. And he really chose hexagons for two reasons. One is he wanted to show there were many contact ports. In fact, ports and adapters is another term for this pattern. It actually has two names, so you will find references to both. And he thought with more sides on it, it would make it more obvious that there were multiple ways to get in and out of it. And as for choosing a hexagon, it was the next easiest regular polygon to draw that was not a rectangle, so he went with that. And finally, he did not want the concept of stacks. We often think of a technology stack. You often see them as rectangles, almost look like bricks in a wall stacked on top of each other. And he really is focusing not so much on a stack, but more of a cocooning kind of concept the layered approach, looking inwardly, not top down. So hexagonal architecture has nothing intrinsically to do with the hexagon shape as well. But if you do a search for it, you will find hexagons are used everywhere in the diagrams for it. When I'm doing my own diagrams, I personally have something closer to this, where I actually do use rectangles to represent these boundaries because I find it easier to draw. But I will be using hexagons in this presentation just for traditional reasons. I'm also not sure that it's an architecture. For me, an architecture is something that kind of envelops the entire system. I think the concepts of hexagonal architecture or ports and adapters can work at many scoped layers. It can work at the large architectural level. It can also work at a much smaller level. And I'll talk a little bit about some of those scopes and layers where it can work. I think it's really a set of design principles, and it's a set of constraints. in that it kind of reduces what you can do. And sometimes by limiting what people can do, it actually makes them more creative. So if you think of an English sonnet like Shakespeare wrote, there's a very restrictive structure, yet that restrictive structure almost allowed the creativity of the sonnet to emerge from it. And if you think being constrained is bad, I'm old enough to remember programming in BASIC. That was the first programming language I learned. And the go-to statement was everywhere, and we used it everywhere. And if you think a big ball of mud is a bad pattern now, imagine a go-to statement where you can just jump to any program line anywhere in the code at any time. You end up with something that's completely impossible to keep track of. So removing the go-to statement constrained us, but it constrained us in a way that we were started to add structure to our code. And through these constraints, I think this induces single responsibility principle, separation of concerns, testability, adaptability, portability, and I'll talk a little bit about them. It's also optional. It's a design principle. It's not a technology. It's not a framework. You're not forced to use it. You can use it to whatever degree you want. You can decide to use it for the whole project. You can decide to use it within your own little portion of it. You can experiment with it on a smaller scale without having to adopt something big that the whole project has to move toward. And I can barely go through a talk without mentioning design patterns, and I'm going to talk about three principles of design patterns: polymorphism, delegation, and orchestration. And I am going to be using my version of UML class diagrams. Green boxes represent interfaces, and I'm also probably going to be using some Java terms. The blue boxes are concrete classes. A triangle with the dashed line is implements. And the scary smiley face here is just some sort of user, probably another piece of software. So the first one is the command pattern, which is just polymorphism. It says I have an interface with a method, and then it gets implemented in the concrete class. And the point of command is it turns behavior from being a function into an object. And once it's an object, it's a first-class citizen in object-oriented programming languages. So we can do a little more with it, like pass it around as arguments, store them in lists, etc. Next is strategy. And strategy says there's more than one way to implement an interface. And we're going to see that later on by saying there's going to be one implementation that will be the production version of something, and another one that may be a test double that gets injected. Template method replaces the interface with an abstract class, and that abstract class references, will have methods, concrete methods in it that reference protected abstract methods, which must be defined in the concrete classes below. It's just a continuation of the polymorphic idea. I'm not going to go into template method or strategy in too much from now on. The next is adapter. And adapter basically says, I want to join the language or the interface with the language of some dependency, and I don't want the two to have to know about each other. So I'm going to do the translation for it. So, for example, the interface, if this was real world, you may have one person who speaks only French, another person who speaks only German, and then someone who speaks both language who can translate between the two of them. Facade is very similar to adapter, although it generally says I am talking to or interfacing with multiple sets of dependencies to try to build something a little bigger. Facade will come in briefly at one point, but most of the time I'm going to talk about adapters. And as we can see here, we kind of have delegation going on here, delegation to polymorphism to delegation to polymorphism. So this pattern kind of replicates itself almost like in a step pattern. The next one is dependency injection. That was mentioned earlier as well. I want all of my concrete classes to talk to interfaces. In the design patterns book, their first design principle is program to an interface, not an implementation. At some point, I have to resolve the interface to a real concrete class. I don't want the class that is, what's going on here? I'm sorry. There we go. I don't want the class that is calling the interface to also call new on the dependency or even go to a creation design pattern to get it. I want it to, there we go. Sorry about that. I want the dependencies to be created externally and then injected in. This is often done at the creation of the construction of these the concrete objects themselves. The dependencies can be passed in as construction. I'm sorry, as arguments in the constructor, or may be a set accessors later on. All right, there we go. And now let's see an example that's a little more real world and rather than just design patterns. I'm going to have a business contract. I'm also going to use the term port. So this is going to be an interface that defines what the behavior is, but not how it's implemented. That usually gets implemented by some sort of business logic that is implements that. And again, this is just usual programming language, object-oriented stuff. Often the business logic delegates to another external support. So that could be a database. It could be a RESTful call. It could be a file system, or file in the file system. We want it to go through an interface as well. So we have contracts on both of these. This gets implemented by an adapter, which goes to the real thing. So I'm going to show red to mean something external from what you're mainly dealing with. And in this case, the external support could be the actual database, the file system, the RESTful call, etc. And the support adapter is going to implement the methods defined in the contract and delegate to that external support. So, for example, if this were a database, the SQL statements might be reside in the adapter. Likewise, what comes into the business contract can often be a framework. So let's assume that your product is a service and it has a RESTful endpoint. The framework might be Spring with its REST definitions in it, and then your adapter would implement and use the annotations for Spring to accept requests from a RESTful as the endpoint from REST, and then delegate it to the business contracts that's going on. And as we can see, we're having delegation, polymorphism, delegation, polymorphism, and this almost looks like a descending staircase. And we would also have some sort of dependency injector that would fill in all the pieces for it. All right, so far I have yet to draw a hexagon. I'm about to get to hexagons. So hexagons are boundaries of convention, like borders between countries or borders between states or provinces or territories. So what do I mean by that? There is no hexagon anywhere in your design. Now, maybe with some annotations from the previous talks, you may want to consider using those as labels, but nothing explicitly has to be in your source code for hexagons. In the same way, boundaries between countries, especially states in some parts of the United States and Canada, are arbitrary. They're just straight lines. At some point, some people decided this line is the boundary. On one side is one state, on the other is the other state. But it does have implications, and it has implications on who are the elected officials in those regions, what are the laws, possibly even who can travel or what can travel across those boundaries. So, for example, since COVID has hit, between America and Canada, there's been a travel ban. We cannot, it's starting to be lifted, but we cannot go back and forth. Other bans could be based upon tariffs, what products can go back and forth between countries. And it's a similar kind of thing within software, within this design. So this is the first hexagon that I'm putting in this design. And this is encapsulating the business logic. So it basically says this is the business logic. It depends upon its own, it implements its own contract, and it implements, and it depends upon the support, but it doesn't know anything else outside of it. So that is what your product does. And then this is the other boundary that defines the remaining parts of your product that interface with the outside world. And those outside worlds might be the Spring frame or the whatever frameworks you're using. It could be whatever external supports you're using. The parts generally drawn on the left-hand side are considered the driver side. That is where requests are coming from some sort of user into your system as a whole. And then on the next is the driven side, and that is the resources that you need to complete your tasks. And I'm going to go now to another example with just a little more detail where I have a user story as a customer, and I'm going to assume the customer's number is 453. I wish to see my pending orders so I can confirm what I'm buying. So this could be something like Amazon or any kind of online shopping. The customer is up here, the orders is in a data store, and they're far apart from each other. So first we would have some sort of service, an order service that defines an interface that says get the pending orders for the customer. That would be implemented by some sort of logic that delegates to two things: some sort of authorizer to make sure that the user is authorized to see this information, and also a repository interface on how to collect it. This is the business boundary of the inner hexagon. And for the authorizer, we have an adapter that goes to an authorization service. So it's basically going to make a get RESTful call to look for the authorization for number 453. And if it returns successful, then it will call the order repo, which is implemented by this adapter, which is going to be a select query that gets the orders for customer ID 453, where the order status is pending. Let's also assume that the customer is coming in through a RESTful interface. So that will be all implemented within the order controller that's RESTful. And then this defines our external boundary. And notice that everything external doesn't really know or care about what's that we even exist. And then finally, Spring, through Spring Boot, could auto-wire all the pieces together through its annotations to put it into place. So what's the advantage of this? Let's say later on we decide we don't want to store the orders in a database. We actually want to store them on a microservice so that the rest of the system can see them. The only thing we have to do is take out the order adapter and put in a microservice adapter. And it's a little more than just a button click. I mean, there is more work that has to be done, but the rest of the system does not know or care. And in this situation now, instead of an SQL query, it's going to do a get orders where status equals pending. I made it look a little different than the previous one. It goes out and gets the information. It comes back as XML. And what I want to emphasize is the user is going to get their information back in, let's say, JSON. It came from the order microservice as XML. So this is where some of the translation happens in this adapter. It's going to get an XML version of the order. It's going to translate it into, in this case, Java-like notation, to be a collection of orders. And then those orders are going to be returned to the controller, which knows that the user wants JSON and will convert it back to JSON to go to the user. So there's two sets of translations going on. Even if the order microservice returned a JSON object, I would not recommend returning it in whole back to the user, even if those two JSON objects look the same, because you can't guarantee they're going to look the same forever. So I like the concept of, plus that would also be passing through information that is about an external vendor or external resource within the business logic. I don't want the business logic to know anything about XML or JSON or anything. I want it to only know what it knows here, which is a collection of orders, and the adapters will do the translation for it. So we heard a little bit about domain-driven design. I'm just going to throw in how some of the keywords of domain-driven design work here. Often we have bounded context. That is basically very similar to object-oriented principles, where you have a class and it has a public method and private internals, and it's the same kind of thing. This describes kind of like almost like a chunk of behavior you want in your system. They will also, within that bounded context, have a ubiquitous language. So we have a language that describes all of the things within the business logic. We also have the ubiquitous language that comes from the framework and the ubiquitous language that comes from the support. They may be different, just as I showed in the previous diagram, that we had JSON, a collection of orders, and then XML. And those get mapped between those ubiquitous languages using anti-corruption layers. And within the business logic, we often refer to this as the core domain. There are 3 domains defined by Eric Evans in domain-driven design. Core domain is the functionality that makes your product unique. It is why someone wants to buy your product. It is the thing that makes you valuable. It's the thing you build. We have supporting domains, and I'm not 100% sure that this is exactly what he meant by supporting domains, but I think it works in this situation as well. And then you have generic domains. Those are things external that you can buy off the shelf. Your business, unless your business is to make a database system, you should probably be using a database system you get from somewhere else. You should not be building your own database system. And then as a bonus, and this has really nothing to do with domain-driven design, the business logic is often aligned with a user story or a use case, depending on whatever type of design paradigm you like to use. All right, so let's follow the dependencies. And this is where I think things work really well with the hexagonal architecture. All the lines with the arrows on them represent dependencies. Even the arrow, even the triangles is an arrowhead representing dependency. And it's kind of like a one-way street. So the framework adapter knows about the framework and it knows about the business contract. But the business contract does not know about the framework. And the framework doesn't really know about the adapter either. So that not only is it dependencies of one thing depends upon another, it also includes knowledge. So when the framework adapter depends upon the business contract port, it has knowledge of that port, but the port does not have knowledge of the adapter. So information flows in one direction. There are no circular dependencies. That's something we always want to avoid. And in this particular design, nothing loops back in on itself. All lines cross the red hexagon inward, which means there is no external knowledge. So our business logic is in this pure little cocoon of only knowing about interfaces that have connections to the outside world, but it doesn't know about anything beyond the red boundary as well. So that gives us a lot of freedom in portability, adaptability, and so forth. The adapters have mostly arrows pointing out. That means nothing really depends upon them, so we can swap adapters out relatively easily. So if we want to move from an external support that was a database to one that's a microservice, we would have to change our adapter, but we would not have to change the rest of the system. Classes with outward arrows can change without major impact. That's what I just said. And also the interfaces work as natural boundary constraints. So when I look at an interface, it really has 2 things to it. It's how it's being used and it's how it's being implemented. Once we have an interface that's reasonably stable, the team that builds the adapters and the team that builds the business logic can work in parallel. They may be the same team members, it may be the same person, but they can work independently and not bump into each other or step on each other's feet because of the way these arrows point the dependencies. And you can see that because within an interface, nothing ever points outward. So nothing will bleed from one side to the other. The only time you would run into issues if somebody has to change the interface, then both sides would be impacted by that. And the dependency injectors are invisible. Nothing points to them. And there's a couple advantages to that. One is I can inject multiple adapters in different scenarios. So I can have the dependency injector for production. I can have one for testing. I can have one for different forms of testing, whether it's unit testing or integration testing and so forth. And not only can we use them to inject multiple sets to inject different adapters, they don't know about each other, so they don't bump into each other as well. So we can have multiple sets of dependency injectors in our system without worrying about them interfering with each other as well. All right, so we can nest hexagons. It doesn't need to be just 2 layers. And since I'm running a little short on time, I'll try to go through this quickly. I have a business object. So in the previous one with orders, a collection of orders, we could have just one object that says I'm an order. These tend to be value objects, relatively small, but all the arrows point in. And this is our original business logic contract. And I want to do some sort of management with it. And rather than just going to a database, I'm going to actually do 2 things with the management of an object. And I use the word decide here because I'm doing more than one thing. I'm going to manage the persistence of that business object. And I'm also going to create a business event notification for that object. So if an order is created, then a business event called order created, if create order is executed, it would persist the order and send out an order created event so that the rest of the system may know what's going on via some sort of events. So we could look at this as another layer. And even in the facade repo, we may decide we want to cache the business object as well as send it to a database so we have a little more performance speed. Each of these have adapters. And then finally, we have the full set of externals. So a request comes into the framework. It gets translated through the adapter. The adapter sends it to the business port. The business logic does its thing. And when it's done, it may send a request to the business object management that says, hey, persist this order or create this order, I should say. That's going to then go through the repository, which will send it out to the business object to persist and possibly cache it so we can get it faster if the user wants to pull it back again. And also send out a business event notification, which would then go to some adapter that would create the actual event and put it on a pipeline such as Kafka to go out to the rest of the system. And if you'll notice, I still obey all the rules that even in the inner hexagons, every time we follow cross a line, we're always crossing by going inward and not outward. So at any point, we say, oh, I don't need to do a business event notification. I can just drop off this lower portion and I'm still good with the rest, and the business logic is not affected by that at all. All right, so this is about legacy code a little bit, and implicit hexagons may already exist. This is based upon a real-world example where I work, and what we had was a service that managed some data. And the data was binary in nature, kind of like Word documents, PDF documents, and so forth. And this legacy code is around 20 years old. So we don't have adapters. This is a monolithic implementation. And let me rephrase that. We do have adapters, but we don't have adapters to call this service. This is a service that's called from within the monolith. So other feature components can just call our interface directly. It doesn't have to go through a special framework. And we kept the documents, the data information out in a database. And we actually did have a repo adapter. So that was not too bad. And it was like that for quite a while. About 6 years ago, it was, yes. However, not everybody went through the data service because the adapter was available. Some feature components went to it directly. It's almost like they talk directly to the database. So as time went on, we realized storing binary in a database isn't the best idea. Maybe we can store this on the cloud. So no problem. We'll create a cloud repo adapter, and it implements the same database repository. But now sometimes they discovered that in some cases this didn't work so well with all of our binaries. So there was logic put in the adapter that sometimes it would send it to the database, sometimes it would send it to the cloud. Because we have two potential adapters, we can't go from the actual business logic over to the repository because you can only have one implementation resolving this at a time. So that meant that every place where we were making calls to the database repository, we have to make calls potentially to two of them. So we have business logic here. And of course, the feature components, some of them are going to go to the cloud repository as well. This was about 6 years ago. Things worked okay. And then recently, we want to move this information to a microservice. And there's business reasons for that. We're trying to move from a monolith more to microservice architecture. And this information we want available to everybody on the overall cloud. And we want to do it a little bit at a time with a feature flag. And this additional just couldn't get it to work. It was really difficult to make these adjustments, kept running into problems. And we're like, oh, what are we going to do? How are we going to get this to work? And what we ended up doing was taking a breather, stepping back and saying, what do we really have here? And what we had were the beginnings of a hexagonal architecture, but not the whole thing. So you may already have some hexagonal architecture elements in your design and may not realize it yet. Once we put this into place, we started to notice a few things. Right off the bat, shouldn't have adapters talking to other adapters. So that was a mistake. This was a big one. In fact, in Cyril's previous talk, he showed an example exactly like this. So that's why I said you're stealing my slides. So we are violating the rule where we have information inside of a hexagon going outside the hexagon. This is also a violation. While the feature components can come in through hexagons, they should come in on the driver side. These were going over to the driven side. So once we realized that, we kind of stepped back and said, what can we do to correct this? And this took a while to do, but we basically removed those and replaced it with a dispatching data repository beside. So, and I put it in bold to represent the fact that this is the only concrete class that gets plugged in as the data repository. So when the data suite is making calls to the data repository, it is only talking to this, an object of this class. And what does it do? It delegates to the other adapters, and it also goes to the feature flag to know when certain things are turned on and off. So now, whenever requests come in for relative to the data on the database, the cloud, or the microservice, we can write to all three. We can attempt to read from all three. We don't actually read from all three. We only read till we find the first one that actually matches. We can turn them on. We can turn them off. And we recently, within the past month or two, released this by turning on the feature flags. And it turns out there was a little bit of performance issues in the microservice portion of it. No problem. We flipped the feature flag off, went back to the previous version. It was running fine. They were able to adjust the performance issues. We turned it back on. Everything worked fine. So this really broke the log jam that prevented us from migrating to this new microservice architecture. And it was all when we started to think of it in terms of hexagons. Now, this is where we are now, but it's not the final product because we really want everything in microservices. We don't necessarily want data in the database or in the cloud. And we can still start to migrate towards that final one. So one of the first things we can do is use feature flags to turn off which adapters we talk to, and that's relatively simple. But then we can start to remove access of knowledge, let me say, of the dispatching facade to this adapter. So basically say, don't even talk to it. So now this has become, for all practical purposes, dead code. So we may want to make sure that it works okay. We don't want to delete it necessarily prematurely in case we do have a problem and have to put it back on. But then let's say we're confident that everything's fine, then it goes away. Similarly, once we feel confident, we can do the same steps to use feature flags, remove references, and then this can go away. Now we're left with a configuration where we have a dispatching facade that only talks to one adapter. So maybe we don't even need this anymore. We can get rid of that, and now we're left with the data suite and the data repository always talking to the microservice. And we can do that. And in all those situations, nothing had to change up here in terms of the business logic for who was using it. All right, so what are the practical approaches to hexagonal architecture? And one of the biggest ones is the ability to test more easily. So we can test our business objects almost trivially, almost trivial. In fact, I don't even know if you have to bother to test them because you're probably going to get them in other tests, which I'm going to show right now. When we want to test our core business logic, remember, it knows about nothing of the outside world. And when we do our implementations in production, we have adapters that connect it to the outside world, but now we want to connect it to tests. So what we have instead is, instead of an injector that injects the production versions, it injects a test double that emulates the contract. It also, instead of having an adapter that calls the contract, these are the test cases that call it. And when it does this testing, it's probably going to create the business object anyway. So the test on this side is probably redundant, and this might be perfectly sufficient to test all of your business logic in complete isolation from all the other dependencies that it needs. And just pointing out that the blue objects do not know nor care that they're in a test environment. We don't have to do anything special for them. The only thing different is we just inject different dependencies, which it should not know or care about. The adapters might be a little harder to test, but they tend to be smaller. They're usually humble objects. And by humble objects, meaning they don't have business logic in them for the most part. They are just translators between two different ubiquitous languages. So in this situation, we can test the framework by emulating the business contract. So we don't have to even stand up anything on the business side of our logic. We can put whatever default behavior we want in here. And again, we can test the adapter. Maybe, but it's not testing it in a full-blown framework. And I put an exclamation mark and a question mark here. You could potentially test it within the framework, but that might make more of your test setup. Let's assume, for example, if you're doing Spring Boot, it's got to start up Spring Boot and run it. And it's not so much a unit test as it is an integration test, but it is possible to do that. If you're testing your support adapters and you're talking, and the support adapter is nice enough that it is an interface, then this is relatively simple to set up. You just have your test double that implements the behavior you want to test with, and then you can test this all you want. If it turns out you don't have an interface and you have to talk to the real thing, This can get a little trickier because you might have to stand up some sort of external support to test it for real. It is possible, but it's just more work to do it. You may also want to do this because you're making assumptions if you're implementing the interface. Those assumptions through a test level, those assumptions may not be what the actual external product does. So when you talk to the real version of the product, that will not only confirm that your support adapter is working as you would expect it to, it also confirms that whatever you depend upon is working as you expect it to. And that gets into something called consumer contract driven testing to some degree. Same thing, the blues are the ones that are actually being tested. Everything else is support for that. We can also do integration testing, where we are using test injectors to basically build the entire bounded context and putting in whatever's needed to create them. And the final one here, your external support, if it's an interface, that's going to be relatively simple to set up. If you don't have an interface, that could get a little more challenging. And also, if you want to test from the framework as well, that could be a little more challenging. And maybe this is something that's done in your CI/CD pipeline, for example. And I can do the same thing with all of my nested hexagons. I did not show the adapters for two reasons. One is because of this nested hexagon, another name for similar architecture is onion architecture, where you have different layers. You may want to test only the red boundary, or you may want to test the blue boundary, or you may want to test this rust boundary, or you may want to test the whole purple boundary. You can test as much or as little as you want as you build this out. As you are testing more parts in this kind of architecture, you are getting a better sense of confidence of the whole, but it's probably going to take a little more work to put those tests together and get all those dependencies correct. So that's a trade-off. You may decide to unit test all the blue code and then maybe do one big integration test at the outside. You could decide to do layers of each ring as you go out, or a hexagonal ring as you go out. That these are all not business decisions, but team decisions as to how much effort you want to put into your testing as you move forward. We also want to avoid vendor lock-in. So the framework and the external supports might often be from other vendors that's not necessarily something you have control over. Vendors can change their APIs and their behaviors. They can change their business terms, such as making things more expensive. Worse yet, they can go out of business. So you could be depending upon something and all of a sudden that vendor is gone and now you're kind of stuck. So you want to be involved with the frameworks and libraries, but not committed to them. So what's the difference between involvement and committed? There's an old joke of a farmer in the morning enjoying his breakfast of eggs and bacon. The chicken was involved in the farmer's breakfast, but the pig was really committed to the farmer's breakfast. So same thing. You want to be involved in the framework and the libraries, but you don't want to be completely committed. So the idea is you don't want the framework to completely encapsulate or invade everything in your business design, because if you ever decide to leave that framework, you're going to be stuck. And we kind of get that with this arrow, because nothing from the outside should bleed into the business logic. And it's the same thing with the arrow here. Nothing should bleed into the business logic side. We might have tight couplings to the framework and the external support. Those tight couplings are going to be limited to the adapters that connect to them. And this should limit the overall exposure, so that if there is an issue and we do have to swap something out, hopefully it's only the adapters that have to be swapped out. And also avoid the external nomenclature that may come from a framework. I worked in Corba many years ago, and it would generate types for us. And Corba was kind of like an old version of REST for client-server communication. it would generate types for us that were very convenient, and we ended up letting those types, which should have stayed right here, we let them invade into our business logic. And then later the business manager said, Corba really isn't working for our product. Can we switch away from it? And we said, not very easily, because it isn't just at the surface. It has gone into almost like cancer inside of our business logic, and we were never able to actually eliminate it. So you want to avoid anything from the outside leaking in. And also another side effect of this is portability. So this business logic doesn't know whether it's running on a web app or a mobile device or whatnot. And as an example, let's assume that what you're really trying to build is a podcast application. So it would look and behave differently on your screen than it would on your mobile app. I'm sorry, on your computer than a mobile app. But the business logic should still be the same. And parts of this is you want to keep internationalization inside. So that means you don't want anything in this logic to make assumptions about the language the customer speaks or geographically where they live. Those adjustments would happen in the adapters. You also want to be form factor independent. I don't want to make assumptions that the person inside of here is on a mobile app or whatnot, or a computer. I want to make those adjustments in the adapter. And those adjustments for localization, like I said, would happen in the adapter. I also want to be careful not to even consider that the user might be on a screen in here and pushing buttons. Because if I'm making a podcast app, I may want to port it to the Alexa virtual assistant, in which case, if I have concepts of pushing buttons to make podcasts play and pause and so forth, that's not going to work for Alexa, because Alexa has no concept of a button. So what you would have in your business contract is a concept of not a button to push, but the idea of play, reverse, whatnot. And then the buttons would be in the adapter for something that's visual, and it would be vocal commands in an adapter for a framework that uses Alexa. And ideally, we would need new adapters as we port to new things as well. And finally, scope and composability. The design can range in scope from the entire system to a service to a user story. And also the design can be composed of other hexagons within hexagons and talking to other hexagons. So here's the big hexagonal boundary. It goes to adapters on this side that they may delegate to other hexagons internally that have their own adapters. And then you have the dependency injection that plugs them all together. So you could theoretically have different smaller hexagons that have different functionality, and you could plug together different products for different customers just based upon some configuration that the dependency injector would know about and we configure appropriately for different customers without having to change your code base. And then finally, that's it. Here's again my contact information. There's several slides with all the references I did not show, but they will be posted online with a link through the YouTube video when that's posted. Thank you.
Thank you very much for this. I hope that it's very dense and there's a lot of things. So hopefully you will share the slides and we'll put that in the YouTube video description so people can take more time to dig into it. But I think you covered everything. I particularly noticed the avoid vendor locking. From my experience, I think in any code base I had to work with, there was this problem of this big library that is used across the code base, like the ORM, for example, and that is stuck in a very old major version that you will need to upgrade at some point, but people are very afraid to doing so because it will require so much work. So when you're here, it's a bit too late and you need to recover from it, and there are ways to do so, but hexagonal architecture is one way to make it simple to do major upgrades, because you can just, it's easy to delete something and replace it with something else, because compartmentalized this external dependency you cannot control. So using this light patterns, I would say like the graphs, they seem big and all. It's just because you're showing that you can nest things and compose things together to build a complex system. But really at the heart of it, as you said, it's like, I really like your first slide with the, okay, you got an interface and that's how you invert the dependency and that's it. So, thank you. I'm gonna have a look at the questions now, and if people have questions, don't hesitate to drop some. We will conclude the conference very soon. So, first question, could you say something about side effects? I'm not sure I understand the question.
Yeah, we want to avoid side effects. You want to have, as I said, everything should point inward with your dependencies and knowledge. Actually, you would have side effects. Yeah. So, yeah, I'm not 100% sure what the question means, but you would still have side effects because there is, like, if your externals are a database, or you're sending a message out or so forth, those side effects still happen. You just don't, and even within the business logic, you may have a concept of needing to persist something. What you don't want to do is have it be persisted on a specific technology. That's where the adapter comes in. It says, oh, you do wish to persist an order in the terms of creating an order or updating an order or deleting an order, but then that might map to a different form of persistence, whether it's, Mongo or MS SQL, something like that.
Yeah, that's true. And to tie it back with previous presentation and livable code and interior design, etc., the fact that we isolate the side effects in one place also make it easier, less surprises in the rest of the code. In most of the code, when you get a user, you don't fire an email like that, especially in a test, for example. Something that will do something in the outside world will be located in this file. So you have already ruled out a lot of code that you don't need to read because you know that this cannot happen here. And it limits what you have to take into consideration when you have a problem with, say, the database or an email.
Right. So let's go. Yeah, let's go back to your email example. So in the business logic, it may have a concept of notify user of something, and maybe even a message associated with that notification. So that would be in the contract. Notify user, here's the message. And then you may have an adapter that says, I'm going to construct an email and send it to the user. So in your unit test, all you have to do is have a spy that says, was I triggered to send a notification? It also means you could theoretically have different ways of notifying your user. You could have email as one. It could have, Twitter as another, some social media. Your user may say, I wish to be informed of things in different ways, and you can let the user pick and choose the means of notification. And there may be notification we haven't even dreamt of in the future. And when we do dream of it, we create a new adapter and plug it in, and it implements the notification. And we don't have to go back and change all the rest of the business logic to manage that.
Yeah, and so to follow up on that, so the business logic could be pure functional, Jim?
Yes. Yeah,
exactly.
it has it has to have an abstract concept of notification or persistence. You can't completely get rid of everything, but it's the dependency. It's a separation of what you want to do from how you want to do it. So what you want to do is notify the user. How do you notify the user? It could be email, it could be Twitter, it could be something else, and possibly even give the user the capability of choosing their form of notification.
Exactly. And final question, is there a reason why not all adapters are humble?
I think they should be humble. I've seen plenty of adapters where they were not humble because they did everything. including the mapping from the RESTful API, the business logic, database calls, and the response going back. That's what it's. Humble is a term. It's really it's a pattern for testing. The idea is if something is hard to test, try to separate that thing, whether it's a class or a method, into the parts that are easy to test and the parts that are hard to test. And hopefully the parts that are hard to test are relatively small, so that the parts that are easy to test is where the bulk of the work is, and then you can do the regular traditional testing. So things that are hard to test, UIs, databases, file systems, RESTful calls, like the actual things are hard to test, especially in a unit test. In fact, they're impossible to test in a unit test environment based upon the definition of unit tests, that they should be fast. So what you do is a humble object has very little, as little in it as possible, so that if you are completely unable to test it, the only thing you may be able to do is a visual inspection through code review and say, yes, it looks good, but and we're trust that it works, and we'll test it later in end-to-end testing. But we don't have to do a lot of exhaustive testing because maybe each method is only 1 to 3 lines long.
Nice. Thank you very much, Jim, for all of this. The videos will be available probably tomorrow, actually, on YouTube. So we're gonna put all the links in here. If you want to catch up with Jim, you can. Well, he put the link on the slide, but you can catch it on Twitter and on Coding Blocks community. So you search for Coding Blocks Slack group online, and you will find it. All right, Adi, are you ready?